All right, so today we're going to go over kind of the key things for your unit exam, which is October the 2nd. Okay. We're also going to, I'm going to kind of tell you what kind of questions are going to be on the test, like how many questions will be on the test. Okay. But again, like key concepts, what kind of things I might ask, right, that kind of stuff. So pretty important information that you're getting here. Reminder that also yesterday I put the unit exam review package on Google Classroom. Okay, so look in the stream for that. It's got some practice questions and stuff like that for you to try over the weekend. Okay, so when we started out this unit, the first thing we went over was a review of scalar versus vector quantities from Science 10. All right, so we do need to remember that scalar quantities have only a magnitude or a measured value, okay, and vector quantities have both a magnitude and a direction. Okay, and that when we're calculating things, vector quantities are calculated in different ways than scalar quantities are, because direction matters when we're calculating vector quantities. Okay. So we went over things like that scalar quantities are things like time, distance, speed. We talked about energy and work, but we didn't actually, those aren't actually in this unit. They're scalar quantities, but they're not in this unit. Okay, and then we talked about the vector quantities in this unit: displacement, velocity, and acceleration. It is important to remember that acceleration is a vector quantity, especially when solving acceleration problems on your unit exam. Okay, now, it's not that I'm going to have, like a bunch of questions, like multiple choice questions saying, which of the following is a vector quantity, which of the following is a scalar quantity, because I'm not. I mean, there might be one, right, but it's not going to be a significant number of marks. The place where what's on the screen right now is important is in a problem-solving question. Okay, so let's say I give you an acceleration problem, and I give you a bunch of information and a context. So a ball is rolling down a hill, starts from rest and accelerates down the hill at 3 meters per second squared for 4 seconds. What's its final velocity? If I phrase a question like that, 30% of you will not give me the right answer. And not because you won't have the right number, but what will you not put on your answer? Downhill. Question asks, what's the final velocity? You would be surprised how many people will just skip right over that part in their minds, go straight to the problem solving, the plugging in, the algebra, all that stuff our brain tells us is important, and then we'll forget at the end that I have to put downhill on my answer because it asked for a vector quantity. And even though I've done everything right up to that point, I'm not going to get full marks. Okay? I'm not going to get a mark to my final answer because it's not right. It's not a vector quantity without downhill on it. Okay, everyone kind of follow me there? That's where what's on the screen right now is important. Okay, that same day we reviewed the use of V equals d over t. This one on the left here, okay, that's speed equals distance over time. Okay, and the one on the right, velocity equals displacement divided by time, right? And the other way, sorry. Okay, this also means that average velocity can mean final position minus initial position over time. Same formula, okay, but that could be applied to something where I'm on a graph, but the graph isn't a line, right? It's like jagged, it's got a bunch of sections. Or it could also be that I might be looking at this formula. Average velocity is total displacement over total time, and that could be for a problem that has many parts. Okay, like we did a bunch of questions where a bus travels this way and does this, and then they travel this way and does this. Okay, and we have to calculate the average over the entire trip. Right, so all of those are kinds of things that we went over. I wouldn't expect a whole bunch of problem-solving marks on V equals d over t. I'm not going to waste a 5-mark question in the written response section of the test on V equals d over t. Okay, but is V equals d over t part of other things? That's part of projectile motion. You're going to need to use it there. Okay, stuff like that. Okay, after we talked about that stuff, we went to graphing. Okay, and we talked about, firstly, position versus time graphs. We did a lab on position versus time graphs. Should you expect to see a position versus time graph on the unit exam? Absolutely. Expect probably to see more than one. Could be one in the written and one in the multiple choice. Okay. Think about what kinds of things I asked you to do with position versus time graphs. I asked you to calculate, displacement during certain intervals. I asked you to calculate average velocity. And if the graph was perfectly linear, I asked you to use y equals mx plus b calculations on it as well. Okay. Now, here's what we need to learn from our 2 labs for the test. If a question on the test says, in boldface, italicized, and underlined font, because it does, using your graph, do the following. Should you use your graph? Yes. Okay? And sometimes it might even say, using your graph and the equation given for it, that would be, this part here, okay? You should probably use the equation given for it, not go to a data table or try and pick points off the graph or something like that. Okay? If it says use the equation that came with the graph. Just some helpful advice from the guy who made up the test. All right, so things you could be asked to do then could be, I might ask you to calculate the average velocity, okay, over the entire trip. Well, okay, I got to remember then on my position versus time graph, okay, what part of my graphing equation represents that average velocity? Okay, or maybe the question will say, using your graph and the equation for it, calculate the position of the object after 100 seconds. Or how long will it take to reach a position of 200 meters? Okay, all of those things can be calculated using the equation for the graph. And if the question says to do it that way, you should. Okay, so remember that y values on a position versus time graph are position values. X values are time values. M, okay, the slope is the velocity. Okay, and the y-intercept would be the initial position. Yeah. Okay, on a velocity versus time graph, okay, you've got to remember, okay, in our acceleration lab, I asked you guys to do 2 things. Didn't go very well, so I would really brush up on those 2 things. Those 2 things were, I asked you to calculate the acceleration of the object using the graph and the line, okay, or the equation for the line. What part of this equation here represents the acceleration? And, okay, because y values are velocities, okay, so y would be vf, b would be vi, okay, x would be time, right? So the slope of that line represents the acceleration, right? The other thing I asked you to do was to calculate the displacement to a certain time, okay? I guarantee you I'm going to ask you that again. So if I ask you to calculate the displacement to a certain time, remember, this is what we're looking for in here. Okay? You would know the time you would need to use. You only calculate the area under the line to do that. Okay? Those are definitely things I'm going to ask you to do. Okay? So, spoiler alert, there's one of each type of graph in the written response. And there's a couple of graphs in the multiple choice as well. Right? The graphs are already built. The equations are on them if they need an equation. Okay? One does, the other doesn't. Right? But you have to be able to use them. Okay, questions on graphing? Right, then we talked about acceleration. We did some problem solving. Expect that there will be at least one acceleration problem on your in the written response portion of your test. Okay, maybe more, but for certain one. And acceleration problems and formulas are also part of what? Projectile motions. We need to be able to recognize when a certain formula applies, when we should use it, okay, things like that. So make sure you're brushed up on that. Okay, and then probably the biggest thing in the unit, vector addition. There are 2 vector problems that are just vectors, and then there's a couple of other questions that may have a small vector part to them. Okay, like projectile motion has a vector part to it if you're talking about projected at an angle. Okay, but there are 2 written response problems that are vector. Have we gone over on several occasions the type of question that I would ask in terms of vector addition on a unit exam. Right? We said that on a unit exam, I would probably only ask a question that involved having like one that goes like this, and one that goes horizontal, or one that goes vertical, and one that goes off at an angle, so it wouldn't take you as long to do. Okay? Expect that that's probably what I'm going to do here, because I wouldn't set you up and then do something else, right? And I would say the other one is likely to be some type of bulk question. Those didn't go so well on our vector assignment. So, okay, as a quick review, if I am rowing across the river, I will end up doing this. Okay, if I'm rowing across, I'll end up doing this. If I'm going across, that means I was actually rowing at an angle into the current upstream, okay, and being pushed back. Right? Make sure you read the question carefully. The context is important.
What's the difference between when a boat headed and when a boat directly went? Is that what that is?
Yes, that's so. If it's headed across the river, that means I aimed that way, but I'm not doing that. Right? I'm not going to end up doing that. Okay? If it says I head into the current, then I'll end up straight across. Okay? So that's what we have to be mindful of. Okay? If the question says it's heading across the river, it's not going across. Okay. Another way to find out for sure, if the question has a part B and it asks how far downstream you'll end up, you're definitely not headed into the current. Okay? Because how far downstream would be 0. You probably wouldn't ask that. Okay? I definitely would. Okay. Everybody follow me on that? Okay? So just read the context of the question. When you read the question on the unit exam, you'll know exactly what type it is. Okay, I've made it very, very clear as to what's going on. Okay, remember we always want to draw all vectors tail to head, which is what I did here. Okay, I drew this one, and then I drew the next one on the head of that one, and so on. Okay, we always draw them tail to head. Okay, and then we find their x's and y's. We use trigonometry, we use Pythagorean theorem. Okay, all of that kind of stuff. We've gone over countless examples of vector addition problems. Okay. Would it be advisable to practice a few of those over the weekend? Yes. Time's a factor. Okay? Time's a factor on the test. You don't want to, take a long, long time to do that, to do the vector addition questions. Okay? We've done a lot of them, okay? But the more you do, the faster you will go. Okay. Then, lastly, projectile motion. You're going to have one of each. Okay? There's one projected at an angle. There's one projected horizontally. We've gone over both types, and that's what we're going to do on Monday. Okay, now a couple of things with regards to your exam. There is a multiple choice part to this. You'll get the little zip grade sheets, okay, the ones where you fill in the bubbles. So when you're filling in the bubbles, have a pencil. Okay, have a pencil. My suggestion is that when you are first filling in the bubbles, the first time through your test, especially if you're a person who has a tendency to change their answers, I would just do that. Okay? And then when I'm done the test, I'll fill it in more. Okay? But what I often have people do is this. They either do it in pen. Don't do it in pen. I'm telling you right now, do it in pencil. Okay? Or they're just lazy. Okay? They do this and they're like, yeah, that's the answer. Oh, no, it's this one. I was wrong. Yeah, it's definitely this one. So I'll just X that one out. Oh, no, wait. No, it isn't that one. It's, and they'll actually write this on the multiple choice form. You know what my phone says when it scans that? It's wrong. You know what my phone is? Right. You can't have 3 answers, okay? I don't have time to go through all of these and check for people writing little notes to me about which one it actually is. Erase the wrong ones and leave the right one, please. Okay? You do that on a diploma exam, nobody double checks your form. Okay? They just got, like a monkey standing next to the Scantron machine firing them through. He's not going to double check your sheet. So don't get in the habit of doing this. Okay? It's just going to come up as wrong, and you don't want it. Okay? Use a pencil. Okay? Erase them completely. Have the right answer filled in and the right answer only. Okay? That said, I say it's advisable to do the whole test in pencil. So have a couple of them for October the 2nd. Okay? Or have a mechanical one with lots of lead or something like that. Okay? Just so you're not having to get up and go use the pencil sharpener, which is super loud and annoying at the back of the room and only works half the time. Okay? So have a couple of pencils ready. You also have to have your own calculator. Okay? You cannot use your phone on the unit exam as a calculator. In fact, I will have a little plastic bin over on the table there. You will deposit your phone in the off condition in that bin for the duration of the test. Okay, you don't get your test until your phone is in that bin and turned off. Right, so you need to make sure that you have your own calculator. I only have one left. Okay, if more than one person shows up without a calculator, one of them is in really deep trouble. And I just don't have enough to lend that. A good loaner got permanently loaned at some point. Okay. All right. Everybody clear on that stuff? Okay. So the exam's not till the 2nd now. Okay, we bumped it back the other day. So that gives you an opportunity Monday and Tuesday to come in and see me for help if you need it, or if you have questions after studying over the weekend. Okay, and remember, that's right, I erased all my stuff. I'll put my help times back up here, but okay, Tuesday is the day I don't have supervision. I am in here all lunch hour on Tuesday in addition to all of scheduled help. So available to answer questions all through lunch hour on Tuesday, half of the lunch hour on Monday, the 2nd half. Okay, so just know that I'm available during those times, okay, if you need it other than scheduled help. All right. Any questions you want me to kind of cover, or topics you would like me to cover in more detail before I tell you more about the test itself? Okay. Sorry, these are the questions from before. Okay, so let's do this one. I'll just erase the part that matters here. Okay, so here's what we've got. A person's rowing directly north across a river at 2.0 meters per second. The current is due east at 0.75 meters per second. What is the resultant velocity of the boat relative to the shore? Okay, so here's my river between these two blue lines here. The rowing speed is 2.0 meters, and it says they're rowing directly north. So that means they're headed this way. Okay, headed this way. But the current is this way. So this is 0.75 meters per second. This is 2.0 meters per second. This is my resultant velocity. But it wants the angle measured from that angle. Okay? That could be important on your unit exam as well. All right, so if I've got that, all I'm going to do to simplify my life a little bit is just redraw my triangle. I mean, this triangle has the same values. It just gets me the angle directly without me having to go 90 minus later. Okay, so to do the hypotenuse, 2 squared plus 0.75 squared. Okay, so the resultant velocity is 2.1 meters per second, and the angle is going to be inverse tan of 2 divided by 0.75. At 69 degrees, that would be north of east, because they actually gave me north and east in the question. Okay, everybody all right with that? Okay. Now here's the mistake that people made on the assignment. Okay. When it asks how far downstream they will be when they get to the other side, which speed or velocity did people use? They used this one. Okay? this point downstream? It does not. This one points downstream, okay? But this one doesn't. All you're ever going to use that resultant velocity for is to tell me what the resultant velocity is. You will never use it for anything else because it points at an angle, slightly across and slightly downstream. If I'm referring to something across or downstream, I need to use things that are pointing in those directions. All right, so I don't think I wrote it. So the river is 50 meters wide. And if I know the river is 50 meters wide, can I figure out how long it takes to get across? Yes, because I'm going across the river at 2 meters per second. Right, so if I go t equals d over v, that's going to be 50 over 2. It's going to take me 25 seconds to get across the river. We're all right with that. Okay. The whole time, all 25 seconds that I'm crossing the river, I'm also moving east, downstream. So if I take this 25 seconds, I can go d equals v times t. That's 25 seconds times 0.75, right? And that'll give me what, 18? 19. 18.75. How about I just type it in? 18.75. Okay, so I'll end up 18.75 meters downstream.
Times squared is 4.
2 squared is 4. That's what I did. I squared the 2. Yeah. Sorry, I probably should have mentioned that when I typed it in. Okay, so that makes sense for both questions? I would say 19 meters downstream. Yeah, 2 significant figures on that. Okay, that's another thing to watch for in your unit exam. Okay, make sure your answers always have the correct number of significant figures because that can cost you marks on the answer as well.
How many questions were there?
I'm going to get to that here in just a minute and see if anyone else has any more questions before I break down the test.
Do you have to write our answers?
If you want, you don't have to, but try and make your answer readily visible so that when I take a glance at your test, I'm like, okay, that's an answer. Because when I'm marking, it's easier to work back from your answer than it is to work from the beginning. Right? If you have the right answer, I don't really need to look at anything else. Right? You got it right, so you get the full marks. Okay. But if you didn't get it right, then I know, okay, that step wasn't right. That step is right. So they only lost 2 marks out of 5. Yeah. Okay. So on that note, is it important to show your work? Yes, so please do. Okay, just a couple of other things here, guys, because they were things that I thought you might ask about the position versus time graphs, right? So if I have this position versus time graph, okay, y equals 1.53 times x plus 3.23, okay, the 1.53 represents my, it is my slope, but what does it represent on this graph? Velocity, right? Okay, the velocity of this object is 1.53 meters per second in a forward direction. Okay, and my initial position in this question was 3.23. Okay, remember, my y-intercept, that's this number here, okay, is where the object was at time 0. So that's my initial position. If this question wanted me to figure out how far the object would go, or sorry, what the position of the object would be after 1 minute, what would I do with that equation? Nope, I wouldn't times it by 2. I'd be solving for y, yes? Right, because y is position, and the question was, what is the position of the object after 1 minute? Okay, how long is 1 minute? 60 seconds. Okay, seconds are, y or x values here? X. So I will go y equals 1.53 times 60 seconds plus 3.23. So basically, here's v times t plus my initial position. That will tell me where my final position is. Everybody follow there? Okay. Similarly, if the question asks me, how long will it take to reach a position of 100 meters? Y is now 100 meters. It's saying, here's your position, 100 meters. What's x when y is 100? Okay, so I would manipulate and go x equals y minus b over m. So 100 minus 3.23, okay, over 1.53. That's what I mean by using the equation for the line. Okay, because in a situation like this, if you just use v equals d over t, will you get the right answer? No. Because if you just use v equals d over t, you're missing that. Okay, you won't be factoring in that you didn't start at a position of 0. You won't get the right answer. You'll get the displacement, not the final position. Okay. All right, with our velocity versus time graphs, again, y minus b over x, this is basically like vf minus vi over t, so it's calculating acceleration. Okay, we wanted to calculate the area under the line. Okay, then we could calculate our y values at a certain time and calculate the area of the triangle and the rectangle. Okay, or we can also remember that this formula also does that. Okay, and it does it using information that would be in this equation. Okay, because the question would probably say, calculate the total displacement to a time of 6 seconds. All right, so it told me x is 6 seconds. My initial velocity is 4.63. My acceleration is 2.3. I can plug all those in there. That's using the information from my graph. Okay, that's calculating a rectangle, the triangle. Yeah.
Would we have a question where we have the equation but not the numbers on?
No, the equation will, I'm just going to use Google Sheets to build my graphs, so you'll get that.
Should that be minus 4.63?
No, because it's positive here.
But I thought the equation was y equals mx. Oh, it is plus.
Oh yeah, but right now it's set up to calculate VF,
Oh.
right? Y is VF.
Okay.
Right? So we're saying VF equals A times T plus VF. That's what it's doing right now. Yeah. Okay, if I have a graph like this, I'm not going to have a graphing equation because it's not a what? It's not a line. Okay, could I ask you to calculate the total displacement on this graph? Okay, on this one, do you have to actually calculate all the shapes?
Yeah.
Yeah, okay, well, it's not a big deal. You guys can do that. Okay, but you could get something like that. Maybe that question would also ask, what's the acceleration between this point and this point? So between 5 and 18 seconds or whatever it happens to be. Okay, so, all right with that. If I had that question, could I use this formula then? Yeah, I could. That would get me VF, VI, and T. I could find it there. Okay, and if I had a position versus time graph with this kind of shape, one of the things I might ask might be, what's the displacement to time of 20 seconds? Well, I started here, so that's my initial position minus my final position, or maybe I might ask for the average velocity over the whole trip, or the total distance traveled. Okay, if it's total distance traveled, then I've got to go, okay, how far did it go here? How far did it go here? How far here? Didn't go anywhere here. How far here? Okay, add them all together. Is that ringing a bell for everybody? All things we did in class multiple times. Some of them on our labs. Expect that they're the kind of things I'm going to ask. Okay. All right. So, details about the test itself. So, we are looking at 17 multiple choice questions. Right? And we are looking at 7 written response. Okay. In the written response, and I've already told you this, so I'm not telling you anything new, but in the written response, you have one projectile motion question, projected horizontally. you have one projected at an angle. You have a vector question. An acceleration problem. A graphing problem. A vector problem. And a graph. So just like I told you before. In the multiple choice, what you can expect is like kind of checking your understanding, checking your basic recall, and very simple calculations. Very simple calculations, right? Nothing that would be worth more than a mark. Like simple v equals d over t, plug in the numbers kind of question, that kind of calculation. Okay, so it's going to be checking things like your understanding of scalars and vectors, your ability to read a problem like student A walks this far, student B does this, what's the displacement of student B, like stuff like that. Being able to read a problem and come up with the answer. Like you have a simple calculation or recognition of the right answer. Okay? There's a couple of graphs. Okay? A couple of graphing questions in there. A couple of questions asking about your understanding of acceleration, kind of what it is. A couple more graphing problems or questions. Okay? And the graphing questions in the multiple choice are basically recognition. They're not asking you to do any calculating, or if they are, it's very simple calculating. They're mostly, here's a graph, tell me what its shape means, or what's going on in this graph, or things like that. Okay, simple recognition type stuff. Okay? And then there's a couple of things on understanding how to represent vectors, okay, how to draw them. And then there's a couple of questions asking about your understanding of the mechanics of projectile motion. No calculations, just the mechanics of it. So, like I said, 17 multiple choice. 7 written. Many of the written have like an A and a B and a C. Okay, especially the graphing ones, they have like A, B, C, D, E. Okay, they've got multiple parts. Okay, the whole test is out of 48. Or sorry, out of 65. So there are 48 marks in the written for 7 questions. Okay, they're worth between like 5 and 8 marks each. Okay, like the graphing ones, they're worth a few more because they have multiple parts. Okay, a vector addition problem can be a 6-mark question. Okay, a simple acceleration problem is probably only worth 4 marks. So, okay, you kind of get the idea of where your marks sit in there. All right. Questions on the test? Okay. A couple of other tips for you for the test.
Are we allowed to come in early at lunch?
Yes. Okay, that was one of the things. I will let you start writing this test at, let's say, as quickly as I can get back off my supervision on Wednesday. Okay, so we'll say like between 12:10 and 12:15. Want to start early and get an extra 20 minutes or so, okay, to write the test, that would be fine. If you already have a provision for extra time, obviously you will get it. Okay, that doesn't apply to everybody, but those of you to whom it applies, to whom you are. Okay, if you have a provision for Google Read and Write or any of that, I will have already made arrangements for that. I actually will be recording my voice and reading the test shortly. Okay, and so you'll have to listen to me because Google Read and Write doesn't do a very good job of physics stuff. It doesn't read numbers and units and stuff very well. Okay, so I just read it. The big thing, guys, is don't stall. And what I mean by that is I see people, they read a question, they don't know how to answer it, so they sit there and stare at it for 20 minutes. And you've got 85 minutes to write this test. You can't sit and accomplish nothing for 20 minutes if you don't have that kind of time. If you can't get a question started within 30 seconds, move on. It'll still be there when you're done everything else. But get everything else done. Don't let a question you don't know how to do keep you from showing me what you do know how to do. Okay, so if you can't get it started with 30 seconds of reading it, move on to the next one. Okay, what I usually do is I read through the test and I rank the questions. Okay, I'm like, oh yeah, I'm gonna rock that one. I know how to do that one. Do it first. Okay, and I know how to do that one. Do it second. Okay, and so on. I get one that I'm not sure of. I leave it for last. Okay, because usually by the time I'm done the other ones, I'm feeling pretty confident now because I've done the questions that I was good at. Maybe they triggered something. I'm like, oh right, I got to do that on that question I couldn't remember how to do. Okay, that's the best way to approach it. Don't just sit there and stare at a question. Okay, I would also recommend doing the written response first. I put it first on the test. Okay, there's way more marks there. 48 out of 65 are in that section. So we want to get that one done. Okay. If you get rushed, way easier to rush the multiple choice than it is to rush the written. So that's what I would do, but it's entirely up to you. Okay. Yeah, that's my recommendations. Okay, if you have this right after lunch, I would say bring a lunch that day. Don't go out for lunch that day. The worst thing that that could happen if you went out for lunch is there's a train and you get stuck behind it, or there's an accident on 32nd Street and you get stuck behind it, or something like that, and you end up late for class. If you're late for class, you don't get the time you're late, and I'm not going to let you sit here into my 34 class because you left school at lunch. I would suggest you bring a lunch that day. Okay. All right, any other questions from you guys? Hey, if there aren't, I would recommend opening up Google Classroom and having a look at the exam review package I posted there. Oh, sorry, about your formula sheets. No, don't bring your own because I don't know how many notes to self you've written on it. I put the formulas for the unit on the front of the test. Okay? So no, you can't use your formula sheet. All right, have at her. If more questions come up, I'm happy to answer them.